Hello and welcome to today's video. In today's video, we have a question evaluate the integral we have on the board, integral of x squared sine x dx. Now, to solve this question, we'll be making use of an integral principle that we call integration by part. So, to solve integration by part, we have the formula that we use. We have integral of u dv will be equals to uv minus integral of v du. Now, you have to be very careful when using this approach. The reason is this, because the first term may not necessarily have to be your u, while the other terms remain the v. It doesn't work that way. So how do we know what is u and what is v? So this is what you do. You make use of the idea of a principle that we call LIATE. So L means logarithmic function, I means inverse function, A means algebraic functions, T means trigonometric functions, E means exponential functions. So the one that comes first between whatever term you have is the u, and the one that comes later becomes the v. So in this case, you see that you have algebraic and trigonometric. X squared is an algebraic function, while sine x is a trigonometric function. So in this case, A comes before T. So that means that algebraic. So that will be our u. So it means that we'll say that u is equals to x squared in this case. Then the remaining part, that is, in this case now, dv, because that is what your formula is saying, u dv. So it means dv now will be equals to sine x dx. So before we proceed, we go ahead to look for du dx. So du dx now becomes 2x. And that implies that du, by the time I cross multiply, will be equals to 2x dx. I want you to keep that handy. Then to get the value of v, all I need to do is integrate both sides of this equation. So I'll say integral of dv equals integral of sine x dx. And that means that from this place, v, when you integrate dv, you get v equals to negative cos x. So by the time you integrate sine, you get negative cos. So there's a whole lot of things to this. Don't forget that the reason why this is working out like this is because you have just sine x. When you have sine 2x, it's a different thing entirely. So now we go back and substitute this back into our integration by part formula. So we say integral of x squared sine x dx now will be equals to uv. So u, what is u? X squared. What is v now? Minus cos x, right? Plus integral of v, which is minus cos x, then du, which is 2x dx. So this gives me minus x squared cos x. Sorry, this should be minus. So this term here should be minus. So minus times minus gives us a plus. Cos x times 2x will be me, that will give me 2x cos x dx. Don't forget the integral sign. So integral of 2x cos x dx. Now, to solve this, I can easily say this is minus x squared cos x plus 2, because 2 is a constant term, so I can easily bring that out. Integral of x cos x dx. So to solve the other integral part, I mean this part, we will also make use of integration by part again. So I'm going to do something like this. Let's pair the board so that we can have this. So I'm going to do minus x squared cos x now plus 2. Now, open a bracket. So we know that in this case, this will be u, right? X will be u. So uv again. So that is x u. Then v will definitely be the integral of this opposite one, the remaining one. So integral of cos x dx. So, and that will give me sine x, right? So minus v. So what will v be? So v is this, which is sine x. Then when you find du dx, so by the time you differentiate x, you get 1. So to bracket 1. Then put your dx. So this gives us minus x squared cos x plus 2 into x sine x minus integral of sine x dx. So now to solve this, this just gives minus x squared cos x plus 2 into x sine x minus, by the time I integrate sine x, I'm going to get negative cos x. So this will be into negative cos x. Now, don't forget that I can add my plus c, right? Because I'm now done with all the integral processes. So plus c is your integral constant, because we are dealing with an indefinite integral, and that means that there is room for approximate error, and that is why we have our plus c there. So this will be minus x squared cos x plus 2 into x sine x plus cos x plus c. And finally, this gives us minus x squared cos x plus 2x sine x plus cos x plus c. And that will be the solution to the evaluation of our integral. I hope you've learned something in this video. I hope to see you on the next one. Thank you.